One of the first things to realize when using a balance is that it is a highly sensitive piece of equipment. To minimize uncertainties when using a balance, you should observe the following guidelines. The same balance should be used when taking a series of measurements. There are small differences between balance units which can cause errors. You should not lean on the table supporting the balance while taking measurements. This can cause vibrations or other forces to affect the balance's measurements. Always use gloves, tongs, or chem wipes when handling glassware to prevent skin oils from accumulating on the glassware, which can throw your measurements off. You should ensure that all compounds being measured are at room temperature. Deviations in temperature can result in errors in mass and weight ratios. You should ensure that the weighing platform on the scale is clean when you start using the scale, and that it remains clean while you take your measurements. Any materials accidentally transferred to the weighing platform could cause errors in your measurements. You should always have all of the sliding glass doors closed when taking a measurement. This eliminates air currents that could affect the measurements. The fluctuations in the balance readout can be caused by any of these items. When using a balance, the display must be zeroed out before beginning any measurements. This can be done by pressing the zero button after cleaning the scale with the doors closed. This will result in the balance displaying the total weight of an object placed on the weighing platform. If only the transferred substance should be measured, the empty glassware can be placed on the weighing platform when the scale is zeroed. This is called a tare weight. To use the tare function, first place the empty glassware on the weighing platform. This image shows the balance's display showing the weight of the empty glassware on the weighing platform. The balance is now zeroed by pressing the zero button as shown. This image shows the balance displaying zero measured weight with the glassware on the weighing platform. In the following video segments, each lab partner can be seen performing one measurement cycle of a blue powder compound. The tared glassware is first removed from the balance, and the blue powder compound is transferred to the glassware for weighing. The glassware is then placed onto the balance's weighing platform, and the door is closed. After allowing the balance's display to settle, the displayed weight is called out to a lab partner who is recording the measured values. This is the initial weight, or the weight of the vessel and compound combined, referred to as WI. The glassware is then removed, and the compound is transferred to the destination container. The glassware is then returned to the balance's weighing platform. Once the display settles out, the displayed weight is again called out to a lab partner who is recording the measurements. This is the final weight, or the weight of the vessel after the compound has been removed. This is referred to as WF. This image shows the calculation used to obtain the actual weight of the compound that was transferred. WI, the initial weight, has WF, the final weight, subtracted from it, which produces WT, the transferred weight of the compound. This image shows the lab notebook that was used to record the values that were called out by each of the lab partners as they performed their weighing operations with the balance. WI, the initial weight, is recorded in the column labeled WI starting. WF, the final weight, is recorded in the column labeled WF final. The calculation result is recorded in the column labeled WT compound. To the right of the WT value, the initials of the lab partner who performed the measurements are noted. The first measurement was made by Gabrielle Marshall, GM, the second by Justin Bynum, JB, and the third by John Higgins, JH.